All right, today we're going to do a fun little problem. I have here two blocks that are on a frictionless surface. Block A has a mass of 6 kilograms. Block B has a mass of 4 kilograms. There's two forces applied. There is a 100 Newton force applied to block A to the right, a 20 Newton force applied to block B to the left. And the first thing we want to do is find the acceleration. Now, if you think about this, you have two blocks on a surface. They're being pushed together. They're going to move together. All right, so they're both going to have the same acceleration. One's not going to take off in one direction, the other take off in the other. They're being pushed together. However, this force to the right is going to overpower the force to the left. So they're going to accelerate in this direction, even though there's a force to the left. Now, so to do this, because they're going to move together, we can treat them as one object for now. So this is kind of like, instead of a 6 kilogram object and a 4 kilogram object, it's 10 kilogram object. So when we do net force over mass, we're going to do 80 newtons over 10 kilograms. So that's 8 meters per second squared to the right. All right, now that we've done that, we want to find the net force on A and the net force on B. Now we're going to look at the two blocks separately. All right, so to find the net force on block A, we're going to take the mass of block A and multiply by its acceleration. So that's going to be 6 kilograms times 8 meters per second squared, which is 48 kilogram meters per second squared, or 48 newtons for short. We're going to do the same thing for block B. So block B has a mass of 4 kilograms. It's also accelerating at 8 meters per second squared. So there's a net force on block B of 32 newtons. Okay, now I want to find the size of the contact force on A by B. This force here, how hard B is pushing on A. And I also want to find the contact force on B by A. How hard A is pushing B. All right, now we know from Newton's third law that whenever two objects interact, they apply the same size force to each other. So we know that these two forces, since they're part of the same interaction, should have the same size, just in opposite directions. Okay, so let's look at the contact force on A by B. So if I look at object A, and I'm not going to draw the vertical forces in here, F1 is 100 newtons. Now, the net force on object A is 48 newtons, which means that this force to the right has to be 48 newtons larger than the force to the left. So this force to the left, which is the contact force on A by B, is going to be 52 newtons. Now, we've already said that the contact force on B by A has to be the same size, but let's just double check that just to make sure we did this right. So I'm going to look at object B. I know there's a force to the left on object B, F2, of 20 newtons. I know the net force on object B is 32 newtons, all right, which means that this force to the right has to be 32 newtons larger than this force to the left. That makes this 52 newtons. And it checks out. It's a beautiful thing. Who doesn't love problems like this?